Hello class, we're about to start section 8.1, part 1, rational expressions, domain and lowest terms. Objective number 1, the domain of a rational function. Rational expression, aka algebraic fractions, a fraction of the form p of x over q of x, where both p of x and q of x are polynomials. The domain of a rational function, all possible inputs or x values, is the set of all numbers except those that would make the denominator 0. Okay, now it says, example 1, find the domain of each rational function by hand. So basically this is what we would do. We would take our denominator and set it equal to 0, and that would tell us our exception. So we would subtract 4 on both sides. We add 3x equals negative 4. Divide each side by 3, and x is a negative 4/3. Now, this is what x cannot equal. So we could put all real numbers, except negative 4/3. So that will be your final answer. Now we go here to B. It says g of a is equal to a minus 5 over a squared minus 3a minus 10. So we would set our denominator equal to 0. Now we know, because we've covered factoring before in Math 31 and also in previous sections of this class, that this factors out to a minus 5 and a plus 2. They equal 0. So we add a minus 5 equals 0, a plus 2 equals 0. So this will give us a equals 5, or a is equal to negative 2. So this would be all real numbers except negative 2, comma 5, or negative 2 and 5. So it's all real numbers except negative 2 and 5. Now we come down here to C and D. Now we look here at C. We have x minus 3 over 2x cubed plus 8x squared minus 42x. So again, we set the denominator equal to 0. Now, we can factor out a 2x because all of these terms here have 2x in common. And that will leave us x squared plus 4x minus 21. And that equals 0. Now we know that this parenthesis factors to be x minus 3 and x plus 7. Now we would set all three of these terms equal to 0. 2x equals 0, x minus 3 equals 0, and x plus 7 equals 0. So this will give us x is 0, this will give us x is 3, and this will give us x equals negative 7. Now, again, this is all real numbers except negative 7, 0, and also 3. Now, we come here to D. We have k of t is equal to t minus 8 over t squared plus 16. So we'll take our t squared plus 16 and set it equal to 0. We will subtract 16 on both sides, and we'll have t squared is equal to plus or minus the square root. Well, actually, I jumped the gun a little bit. So this is supposed to be t squared is equal to negative 16. Now we're supposed to take the square root of both sides. So this will give us t is equal to plus or minus 4i. Now remember that this is not a real number, so our answer could be all real numbers. Or you could write it out as all real numbers. Okay, so we go to objective 2. It says simplifying rational expressions. it says reduce the fraction 12 over 15 to lowest terms. Now we know we could break 12 down to 3 times 4 and 15 to 3 times 5. These 3's will simplify out and you're left with 4/5. Now we come here. They want us to reduce the fraction to lowest terms. We can factor out a 2 and we have x minus 3. And our denominator, this is the difference of 2 squares, so it'll be x minus 3, x plus 3. These x minus 3's will simplify out, and it'll be 2 over x plus 3. Now, important, to simplify, reduce an algebraic fraction, you must have the factor form of the numerator and denominator. Reduce factors only, never reduce add-ins. Now, let's go through this. When it's referred to as never reduce add-ins, that means like if you said, okay, I want to simplify out this x and this x here. So that's what it's meant. Like if I had x plus 2, let's say over x plus 3. We cannot simplify these x's out and say it's 2/3. No, they would have to be like if you had x plus 3 over x plus 3, these both can simplify out to 1. That's what this statement means. Now we look here at a. In our numerator, we have x plus 2. In our denominator, we know we can factor this to x plus 2 and x minus 4. These x plus 2's will simplify out, and this will leave us 1 over x minus 4. Now we go here to b. Our numerator, it factors out to x minus 7 over times x plus 2. All over, our denominator factors to x plus 6 and x plus 2. These x plus 2 simplify out, and we're left with x minus 7 over x plus 6. Now we scroll down here to c and d. Now c, we need to factor the numerator and the denominator. In the numerator, we can factor out a 4x, and that will leave us 3x plus 2. In our denominator, we can factor out a 4x squared, and that will leave us 2x squared plus x minus 3. Now, we could also, in our denominator, this parenthesis could be factored. We have our 4x squared, and then, oh wow, it's supposed to be 2x. Would be 2x plus 3, and also x minus 1. Now, if you look here, the only thing that we can simplify out are these 4's and the x and the x squared. We know x goes into x once, x goes into x squared x times. So our final answer here would be 3x plus 2 in our numerator. And in our denominator, we would have x, and then in parentheses, 2x plus 3 and x minus 1. And this would be our final answer for that problem. Now we go here. In our numerator here, if you notice, we have 4 terms. So we could group the first 2 terms and group the last 2 terms. The first 2 terms, we can factor out an x squared, and we'll be left with x minus 3. The second 2 terms, we can factor out a positive 3, and we'll be left with x minus 3. All over in our denominator, first we'll factor out a negative 1, and we will end up with x squared minus 9. So next, we will have x squared plus 3 and x minus 3 in our numerator. In our denominator, we'll have our negative 1, and this is the difference of 2 squares. So we have x minus 3 and x plus 3. Now these x minus 3's will simplify out, and we will have x squared plus 3 all over negative 1 times x plus 3. Now, since we have this negative 1, we could just make this whole fraction a negative. It'll be x squared plus 3 over x plus 3. we brought our negative sign in the middle. And we're done.